All right, this is Chapter 2, Section 2 on operations with rational numbers in decimal form. So what we've all agreed on is that for this chapter, the important parts will be to be able to estimate your answers and then to be able to effectively use your calculator to make sure that your estimation was close. If one of your numbers happens to be off, either you estimated incorrectly or you calculated incorrectly. So the first question said, would you expect the subtraction question of negative 3.5 minus negative 4.3 to give a positive answer or a negative answer and explain? So what I would like you all to realize is that the simplest way to subtract integers is to never subtract. If you take your question, negative 3.5, change it to addition and use the inverse of the second integer, or the opposite, excuse me, of the second integer, you will end up with an addition question which is much easier to contextualize or to put into a form that's more digestible. If you have a negative decimal number, you can think of it as debt. If you have a positive decimal number, you can think of it as assets. So in this particular case, you have more assets than debt. In that case, you would expect this answer to be more positive than negative. So yes, the answer is it would be more positive, because when you change it to addition, you can clearly see you have more positive things. And if we estimated it and said we have negative 3 plus a positive 4, remember back in the day, you used integer chips. And really what you were doing is, what do I have more, positive or negatives? And how many more was really a canceling of each other out to get that positive 1 answer, right? So the same thing is true here. So when I do that, I want to know how many more positives did I have than negatives. And in this case, if I have this, I would take my 4.3. 4.3. Oh, it's over here. Let's make this calculator smaller. Can I do that? No. I would take my 4.3 and I would take away 3.5 from it, and it would tell me I have 0.8 more. So my answer is positive 0.8. Now, obviously, the easier way to do that with a calculator. Let's take it. If I have a scientist standard. No, it's still not. Can I make it smaller? There we go. Perfect. If you put in your calculator 3.5 and you want to make that negative, there's this plus minus button right here. On my calculator, yours is a different place. So change it to a negative and then add to it a positive 4.3. You don't need to put the positive symbol in because it's understood to be that. And then press equals, and you'll still get the same answer of 0.8. So get used to using this button here, the positive negative button. Your second question, how do the values of the following two products compare? The answer for this is they're going to be the same, because if I take, let's just make it a simpler question. If I took this question and said, what is the product of these going to be? So if we look at this, how I would solve both of these is I would ignore the integer signs, say what's 2 times 3? It's 6. What's 2 times 3? It's 6. Opposite integer signs, both of them are going to be negative. In this particular one, I don't care what the product of these two numbers is. I just know that since they are the same numbers, whatever answer it's going to be is going to be the same. And because this is a negative times a positive and a positive times a negative, that same number, regardless of what the product is, will have a negative sign, and they will be the same. In the third question, Leslie evaluated these two questions. Do we have this as part of it? Yeah. Zach evaluated the same expression as negative 4.5. Who was correct to explain? So here I'm going to take my calculator right here, and I'm going to put it into the calculator to see if it does the answer without using BEDMAS. So 2.2, I'm going to change it to negative, plus 4.6 times 0.5 negative, and if I press the equal sign, it will tell me the answer is 1.2. Negative 1.2. So Leslie was right, according to my calculator. Now what I'm going to do here is I'm just going to make sure my calculator used BEDMAS properly. So I'm going to write down the question, and I'm going to do my own BEDMAS with the calculator. So the first thing I know I need to do is the multiplication. So I go 4.6 times negative 0.5, and press equals, and it says negative 2.3. So this is negative 2.2 plus negative 2.3. Am I right so far? Yeah. And now I'm going to take my calculator again and go 2.2 negative, plus, I can do this with a calculator, 2.3 negative equals negative 4.5. Oh my God, who was right? So the first time I did it with the calculator, it said Leslie was right. The second time I did it with bedmass and wrote it out, I had Zach right. Who was correct? Zach was correct. So the moral of the story is just because your calculator tells you an answer doesn't mean it's correct. If I didn't take the time to write it out as a bedmass question and simplify each step using the calculator and just put this in, my calculator did this first and then it did this first. So it did addition before multiplication, and as a result, it got the wrong answer. So please make sure, unless you're very skilled with the art of calculator use, make sure you write it out. You can still use your calculator, but it's important that you write out your bedmass question. Question 4, estimate and calculate. My estimation for this will be 1 plus negative 3, which will be an estimation of negative 2. An estimation for this will be 5, take away 3, which will be positive 2. My estimation for this will be negative 4 plus negative 6, which would be negative 10 as an estimation. And my estimation for this will be keep, flip, change, because I'm never going to do subtraction. And negative 1 plus positive 7, I think that's right. My estimation will be positive 6, okay? And I don't think I'm going to waste time using the calculator. Yes, I will. I'll waste time using a calculator. Why not? Let's go bring it down. Where can I put it that you can see it? I'll go over here. So the first one, 0.98 plus 2.91. Make sure you change that to a negative. Equals 1.93. My estimation was negative 2. That's pretty close. The second one, 5.46. Take away 3.16. My calculation is 2.3. My estimation was 2. The third one, 4.23. Change it to negative. Plus 5.75. Change it to negative. Equals negative 9.98. My estimation was negative 10. I'm pretty close. And the last one, 1.49. Change it to negative. Let's just do the takeaway this time. I'm going to ignore the fact that it was a keep, flip, change. Takeaway 6.83 negative equals a positive 5.34. My estimation was 6. We're good. The next one is the exact same thing, except it's multiplication division. So my estimation for this will be 3 times negative 3, which will be a negative 9. If I use my calculator, and I get 2.7 multiplied by 3.2 negatives equals negative 8.64. My calculation and estimation were pretty close. My next one, I am going to estimate using money. So $3.25 divided into piles of $2.5. I can make a pile, but I can't make another pile. So my estimation is going to be, so I can make a pile, but I can't make 2 piles. So 1 decimal something. Not quite sure what it is, but 1 decimal something is all we need. A negative divided by a positive is a negative. So my estimation is going to be negative 1 decimal something. I have $3.25 divided into piles of $2.50, negative 1 decimal something. Take my calculator, 3.25, which is negatives, divided by 2.5, and I get negative 1 decimal something, so my estimation was cool. The next one, estimation will be negative 6 times negative 6, which will be positive 36. Grabez-vous ton calculator. And go 5.5 negative, multiplied by 5.5 negative, 30.25, pretty darn close to 36. And finally, the last one, my estimation, if I have $4 and something, we'll say $4, divided into piles of $1 almost. So we have $4 and something divided into piles of $1. I can make just over 4, and since it's negative divided by negative, it's going to be negative 4 decimal something. I have no idea what yet. Negative 4 decimal something. Grab my calculator. 4.37 negative divided by 0.95 negative equals 4.6. My estimation was 4 decimal something, so I know I'm right. Question 8 is a bed mass question involving estimation and then your calculation. So I'm going to do estimation first for A. So negative 2 times 3 plus 4 times negative 2. If I rewrite each of those to their nearest non-decimal whole number, that's what I would get. I would get negative 6 here, and I would get negative 8 here. Got to do my multiplication before addition. And negative 6 plus negative 8 is negative 14. So my estimation for question A is that. Okay? Negative 14. I'll make a note of that up here. Negative 14 is my estimation. I'll erase that, and then I'll copy down the question. So negative 2.1 times 3.2 plus 4.3 times negative 1.5. Using a calculator, I'm going to go 2.1 times 3.2 is negative 6.72. Negative 6.72 plus, bring it over here now, 4.3 times 1.5 is negative 6.45. Add those two suckers together. Negative 6.75 negatives. Or no, 7.2 or 7.5. Oh, hello. 7.2. Backspace. 2. Plus 6.45 negatives equals negative 13.17 is a calculation. My estimation was negative 14. Bob's your uncle. That was pretty close. B. My estimation for B will be negative 4 multiplied by 5 take away 6. My estimation for B will be that. Do my brackets first. So negative 4 times 5 take away 6 is negative 1. And 4 times negative 1 is a 4. So when I estimate it, I say my estimation will be approximately positive 4. Take your calculation. I'm going to write this down here. 4.8 take away 5.6. I'm going to do my brackets first. 4.8 take away 5.6 is negative 0.8. Multiplied by 3.5. Negative 3.5 multiplied by decimal 8. Negative equals 2.8. My estimation was 4. My calculation was 2.8. That's probably pretty close. Probably pretty close. When's the last one of all of the evaluations? Is this one here? I'm going to... Okay, question B. So question B says negative 3 bracket, negative 3.5 bracket, 4.8 minus 5.6. I think I just did this one. Okay, so now with the calculation. Sorry, B. So we're going to take our calculator. I'll write this out actually. And I'm going to do what is 4.8 take away 5.6. I know it's going to be negative 0.8. So underneath it, we're going to simplify those brackets to be negative 0.8. Then I'm going to take my calculator one last time. 3.5 negative multiplied by decimal 8 negative equals positive 2.8. And that's my calculation for B. And finally for C, by the way, this one right here, if we look for C, this here and this here, those are square brackets. And the reason why we're using square brackets there is because inside them, we have round brackets, and we don't want to have round brackets next to round brackets. So they differentiate those with square brackets. Okay. So if I was to estimate this, I would do negative 1 multiplied by, I guess I should use square brackets, multiplied by 2 minus negative 0.5 and square brackets. I would keep flip change. I would make this 1 actually. So keep flip change plus positive 1. 2 plus 1 is 3. I go back to my round brackets now because I don't need square. And negative 1 times 3 would be an estimation using simplified numbers in a bed mass question of negative 3. Now, if I calculate these, take my calculator out and go, what is 2.3 take away 0.5 negative? Equals, it is 2.8. Put that now in round brackets because I don't need the square brackets. Multiply, oh, sorry, clear. 1.1, is that negative? Yes, it is. Negative. Multiplied by 2.8, and the answer is negative 3.08. That's the calculation. So my estimation was negative 3. My calculation was negative 3.08, so we were pretty close with our estimation. Question 10 says, in Regina, Saskatchewan, the average mid-afternoon temperature in January is negative 12.6 degrees Celsius. The average mid-afternoon temperature in July is 26.1. How many degrees colder is Regina in January than July? So for this one, this is one of those useful times where we can use a number line. So I'm going to use a number line to save space. I'm going to use it this way here. And I'm going to put 0 degrees Celsius right here. And in the winter, in January, I'll put down here, January, it is negative 12.6 degrees Celsius. And in July, right up here, it is 26.1 degrees Celsius. And the question is, how many degrees colder or hotter is it between the two? So we're really looking for the difference here of these two temperatures. So from here to here, if I grab my highlighter, that's 26.1, and this is an additional 12.6. So we can clearly see, to show the difference in temperatures, we have to add the two numbers together, which means the difference in temperature between July and January is 38.7 degrees in total. Question 11, we have a similar question. On one January day in Penticton, British Columbia, the temperature read negative 6.3 degrees at 10 a.m. and 1.4 degrees at 3 p.m. What was the change in temperature? So for this one, for A, I'm going to draw a vertical line this time, and I'm going to put 0 degrees here, 0 degrees Celsius. I'm going to put negative 6.3 degrees Celsius here, and 1.4 degrees Celsius here. What was the change in temperature over that time? Again, we see clearly that we're going to have to add these two together. So the change in temperature would be the sum of those two, which would be 7.7 degrees Celsius. So the change in temperature would be an increase of 7.7 degrees over that time period. Now B requires an extension. It says what was the average rate of change for that. So if it increased 7.7 degrees, we first have to figure out how many hours was it. So from 10 to 11, that's 1 hour. From 11 to 12, that's 2 hours. From 12 to 1, that's 3 hours. From 1 to 2, that's another hour. And from 2 to 3 o'clock, that's 1 more hour. So between 10 a.m. and 3 p.m., there are 5 hours in total. So if I take the change in temperature, which was 7.7 degrees increase, and I divide it by the 5 hours of that 7.7 degree change occurred in, grab my calculator, 7.7 degrees temperature change over 5 hours divided between the 5 hours is an average temperature of 1.54 degrees Celsius on average per hour. So the change in temperature over the course of 5 hours was 1.5 degrees Celsius. Question 12, we have a pelican dives vertically from a height of 3.8 meters above the water and then catches a fish 2.3 meters underwater. Write an expression to use the rational numbers to represent the length of the pelican's dive. So the first thing I'd like you to be able to do is take this and draw a picture. So I'm a great artist, and there is a picture of a pelican. And the pelican is above the water. There's my water. It dives from a height of 3.8 meters. And then it goes underneath the water an additional 2.3 meters, or negative 2.3. So what is an expression using rational numbers to represent the length of the pelican's dive? What we are looking for is the difference between the height and the location of the fish. So 3.8 meters, take away the difference of underwater would represent this. This would be the difference between the two. The difference between the height and the distance underwater. Of course, when I do that, I want to keep flip change. And the total distance of the Pelican's dive would be 6.1 meters when I add those two. So therefore, the difference between where he was when he started and the difference between where he ended up is 6.1 meters in total. Question 13, similar to the last one, a submarine was cruising at a depth of 153 meters. So here's our water for A. And I'm going to start it at right here. There's the submarine. I guess that looks like a submarine. The submarine was at a depth of negative 153. Negative 153 meters. Now, it says it rose, which is a positive value to rise, at 4.5 meters a minute for 15 minutes. So it's going to go up 4.5 meters a minute for how many increments of that? For 15 minutes. What is the new depth of the submarine? So it says, what is the submarine's? So what I want to really be able to do is write an expression properly. So if I start with my depth of 153, and to it, I add the change in depth, which is, in brackets, 15 meters multiplied by rising 4.5 meters per minute. Oh, I should use square brackets there. Whatever, we'll just keep it like that. This should be an expression that shows the total change in altitude, because this is rising. We know that this is going to be a positive value because we're multiplying 15 positive increments or 15 minutes of going up 4.5 meters. So we take that negative 153 where it started and we add to it the product of 15 and 4.5. 15 multiplied by 4.5 is an increase in height of 67.5 meters. So we take its depth, which is negative 153, and we add to that its positive change in altitude or depth of that. That means it is now only 85.5 meters, 85.5 meters under the water after that duration. The second part says, how much longer will it take to rise to the surface? Ooh, this is a great question. So if I erase this and say, well, now it's at negative 85.5. So I want to say how many minutes. So I'm going to make x equal to the number of minutes it's going to take. And I'm going to try and make an equation. So 4.5 multiplied by the number of minutes will be an algebraic expression of 4.5 times the number of minutes. That is going to be, I got to start with something first. Constant first. The depth of negative 85.5 plus that 4.5 multiplied by the number of minutes. Those two combined have to mean the surface of the water. And what you have to realize is the surface of the water is at 0 meters above or below sea level. Okay? So the depth of the submarine plus the number of minutes it's going to take it going up 4.5, those two together have to equal 0, or the surface of the water. So if we solve this using algebra, I'm going to isolate by adding 85.5 to both sides. I'm going to get 4.5x equals 85.5. Divide by the coefficient of 4.5. Take my calculator and go 85.5 meters divided by 4.5 meters a minute will tell me it's going to take 19 minutes. X equals 19. Or the number of minutes required for that submarine to reach the surface will be 19 minutes. Question 14. Seda owned 125 shares of an oil company. One day the value of each share dropped by 31 cents. The next day the value of each share rose by 18 cents. What was the total change in the value? So we're going to call this day one. So day one. She had 125 shares. And each one of those shares dropped 31 cents. We're going to multiply it by negative 0.31. So all 125 shares dropped by a value of 31 cents. That means on that first day, the value of that stock went down $38.75. Okay, that's on day one. On day two, those same 125 shares rose 18 cents in value. So if I think of it in terms of that, all 125 shares times 18 cents in value for each of them, that means it was $22.50 it rose on day two. And it says, what was the total change in the value of Citus shares? So after you multiplied those two, you then have to add them together, right? Because day one plus day two is the total change. So if I'm going to write that as an expression, day one plus day two will equal the total change. The expression of 125 plus negative 0.31 plus 125 times 0.18. That makes sense now if I put day one plus day two. So the change in day one was dropping 38.75. If I follow BEDMAS, I got to do my multiplication first. The change in value on day two was going up 22.50. When I combine those two, 38.75 negative plus 22.50 is a change in net value of $16.25 in total. So overall, over those 2 days, the value of her stocks dropped $16.25. Question 15, in dry air, the temperature decreases about 6.65 degrees Celsius for every 100 meters increase in altitude. The temperature in Red Deer, Alberta, I got to take this and shrink it for a second. Let's see if I can shrink it. Oh, perfect. The temperature in Red Deer, Alberta was 10 degrees Celsius on a dry day. What was the temperature outside an aircraft at 2.8 kilometers above the city? So again, this one lends itself well to a picture. Here is ground level, which is 10 degrees Celsius in Red Deer, Alberta. And the plane, well, that's a good plane. No complaining about that. The plane was 2.8 kilometers above the surface of Red Deer. For every 100 meter increase, it decreases by 0.65. So I want to know how many 100 meter increments are there in 2.8 kilometers? Well, a kilometer is 1,000 meters, so 1 kilometer would have 10 100 meter increases, 2 kilometers would have 20, and 28 kilometers would have 28 100 meter increases, right? So if all 28 of them were to decrease in temperature by 0.65, there would be 28 increments of dropping this many degrees for each 100 meters I go up. Take my calculator and say 28 increments of 0.65 negatives will equal negative 18.2. So therefore, it's going to be 18.2 degrees colder up in the aircraft, which means it will be negative 8.2 degrees up here. Because it started off at 10 degrees Celsius, if it drops 18.2, the difference between them is that. Now listen, here is the important part. What I would like you to have done is this. 10 degrees Celsius combined with plus a change in temperature. This is what it looks like as a BEDMAS question. This is the ground temperature plus the altitude change. Those together, if you add those together, you'll have the current temperature of the plane. This is 10 plus negative 18.2 when I use BEDMAS, which would be negative 8.2 when I simplify it. Okay, that's how you would set it up as a complete integer statement. And the last one says, B says the temperature outside an aircraft 1,600 meters above Red Deer is negative 8.5 degrees. What is the temperature in the city? So this is slightly different. This is, we don't know what the temperature in the city is, so it's going to be X degrees Celsius. But up in the plane, we know that it's negative 8.5 degrees Celsius. And the plane is 1,600 meters above the ground. So we knew if we replace this one right here, I'm going to put this one over here with red. This number is now not 28, it's 16 because it's 1600 meters multiplied by the change in altitude, which is negative 0.65, right? So X, which is the temperature on the ground, plus this has to equal negative 8.5. So I'm going to write that as X plus 16 times negative 0.65 will equal the temperature on the ground, sorry, in the plane, excuse me, of negative 8.5. So we're just taking this temperature here, which we didn't know because before it told us the ground temperature of 10 degrees. Here, it says, what is it? So I'm going to replace it with the variable x. Instead of 28 increments, since it's 1,600 meters above the ground, it's going to be 16 times the change in temperature. And it tells us that the temperature in there. So we're going to simplify this. X plus 16 times 0.65 equals negative 10 point, was that 10.4? I think it was. Yes, it was. Plus negative 10.4, or instead of writing it that way, I can simply say subtract 10.4 will equal negative 8.5. I'm going to add, now I have an algebraic equation, add 10.4 to both sides, and x will equal the sum of negative 8.5 combined with 10.4, 1.9, and therefore the temperature on the ground, or in red deer, the temperature in red deer, I spelled that wrong, was positive 1.9 degrees Celsius. And that is the end of our questions.